Hi class, let's take a look at example 3. In example 3, it's a bit tricky because of the way that the claim is actually given. So let me just write out the claim. So in this case, the claim is that sigma is equal to 12. So this represents a two-tailed test. Our degrees of freedom are going to be technically 16. And this one, it's only going to have it's only given one test statistic, but the actual region for the population has two critical values. So let me actually put this one here. So your test statistic is given as it's the one on the right. So in this case, this particular one, it's on the right, and it's going to be 22.1. Now, if it was a right tail test, you would only be looking at this area. But technically, because of the claim of equality, this is supposed to be a two-tail test. So technically, there is supposed to be another value on the left. And in this case, it's not given. The reason that it's not given is because it's not needed. It's based on how the table is technically given, or the code that we're using. So remember that on the population, so let me put it in this color, this happens to be C. This is alpha divided by 2, and this region here is also alpha divided by 2. So when we find the p-value, if it's a two-tailed test, we typically, for the chi-square distribution, only find one region, multiply times 2, and that would be the other one. So most of these problems are going to be in this format. It feels that it's missing information, but you don't need it. It's based on how the table is actually, well, in this case, written. So let me actually run the code, and your actual code is going to be the chi-square CDF. We're looking at 22.1 to a very large value, and then our degrees of freedom are going to be 16. So let me close that up, and that's going to be the area to the right. So you would just have to multiply that times 2, and that would be the p-value. So the total area above the first one, it's approximately 14. So let me just write it as this value here. It's approximately 0.14, and this value here is 0.14. So your p-value, it's going to be approximately 2 times, and let me just write the value from the calculator, 13,999, and then a 2. I'm just going to go a lot of decimal places. So 13, 1, 2, 3, 4, and then a 2, which is going to give us a approximate p-value of 0.27998. So 0.27 998, or if you just round it to 2 decimal places, 0.28 would be perfectly fine. And that would be it for this one. Let me just put the code. And in this case, chi-squared CDF from 22.1 to a large value, and then 16 degrees of freedom. I do want to see that on this particular problem, there was a multiplication by 2, just to be clear. And then, well, technically, if you were to see a problem similar to this in the homework assignments, they would have just calculated the total area to the right, and then from here, just multiply it times 2. We don't actually need the value on the left to find the p-value on a two-tailed test. They just have to tell you if it's on the right or on the left. And then with that information, you just find one area, or technically one tail, and then multiply it times 2. So the approximate p-value for this specific test, which we don't have all the information on, it's about 0.28.